Good morning to the panel, Dr. Muzame, and to the panel from the industry. I hope you all doing well today. Thank you for giving me the opportunity to present before the esteemed panel. My name is KARTIKEYAN. My metric number is AA19188. I am here to present my final year project, which is entitled The Effectiveness of In-House Device Betterment to Measure the Shear Wave Velocity of Peat in Pahang. Well, let's get started. Peat is an organic soil layer formed by the accumulation of partially decayed biomass and serves a vital carbon reserve. Southeast Asia is the home to over 60% of world's tropical peatlands, with the peat swamp forest on Borneo Highland standing out its significant region. However, peat poses challenges in geotechnical parameters due to its dynamic properties, including low shear strength and high compressibility. These characters make peat soils unsuitable for construction and raise concerns about the sustainable use of peat resources. Understanding the peat behavior of peat and finding solutions for its utilization are crucial for preserving this valuable ecosystem and ensuring environmental sustainability. The aim of this project is to utilize our in-house device is called Betterment to measure the shear wave velocity of peat. Our first objective is to thoroughly examine and understand the properties and characteristics of peat. Peat is being a unique organic soil layer, presents distinct level and requires in-depth analysis to grasp its behavior and composition. The second objective is to utilize our innovative in-house device, Betterment, to measure the shear wave velocity of peat soil. Shear wave velocity is a crucial parameter in determining the stiffness and the strength of the soil, enabling us to assess its sustainability for construction purposes. By achieving these objectives, we aim to contribute to the scientific knowledge and understanding the peat soil. Furthermore, the data obtained from our measurements will provide valuable insights for sustainable land use planning and engineering practices in areas with peat deposits. The evaluation of shear wave velocity (VS) in peat soil poses a significant challenge due to the limitations of traditional laboratory testing methods. To address this problem, our objective is to develop a portable in-house device that accurately measures shear wave velocity in peat soil. This device would enable in situ testing, offering a cost-effective and efficient solution compared to laboratory procedures. By providing reliable and accurate results, our aim is to enhance our understanding in geotechnical properties of peat soil and improve earthquake investigations. More effective engineering practices. Ultimately, the innovative solution will save time, resource while delivering valuable data for more effective engineering practices. Now let's talk about the scope and limitation for our project. This study focuses on evaluating the shear wave velocity of peat soil in East Coast region of Malaysia, specifically in Pekan Maran Gebeng, Pahang. The goal is to compare the readings obtained from the in-house device Betterment with established parameters despite potential slight differences from the laboratory testing. The shear wave velocity will be determined using the formula, which is Vs equals to square root of G per rho, where the G represents the shear modulus and the rho represents the density of the medium. It is important to recognize that the study scope is limited to the specific region and soil type, and the findings may not be applicable to other areas. The limitations of the in-house device and variations in peat soil properties should be considered when interpreting the results. According to the research methodology, we collect the sample from 3 different places, which are Pekan, Maran and Gebeng in Pahang, as I stated before. All the lab tests were carried out in Soil Mechanics and Geotechnic Lab, which is located at the UMP Gampang, Pahang. I carried out several experiments, which are 1 post scale Macintosh probe, pH test, moisture content test, fiber content, direct shear bore test, specific gravity, Atterberg limit, bulk density and hydrometer test. Now this was the flow chart that I used to carry out the procedure through my FYP journey. This is the Gantt chart that I used so that I could finish the project within the time frame without delaying the project submission. Now this is the image of the in-house device, which is called the Bender Element Tester, and in short we can call it as the betterment, where I use this betterment to measure the shear wave velocity of pit soil. Now let's move on to the results and discussion of this project, where this is the graph, the first graph that plotted where the shear wave velocity which take up from the betterment, which is the device, in-house device, where I plot the shear wave velocity against the frequency. The frequency was changed to get the optimum shear wave velocity of the soil, because when the pit soil have a low shear wave velocity, we tend to set the frequency from higher to lower in order to get a optimum shear wave velocity for the pit soil. So this graph contains the shear wave velocity of Pekan, Maran and Gebeng soil. Next, this graph was plotted from the value which was obtained from the lab tests which I carried out earlier. This graph was plotted under shear strength, which is SU, which was taken from the direct shear bore test against the shear wave velocity. Now let me show the final graph, which is the important graph, where I plotted the shear wave velocity from the lab test against the shear wave velocity from the betterment to find out how effective the shear wave velocity value from the betterment is. When I plot this graph, the values were very closer to the trend line, and also the R square value is more than 0.95, which is 0.9907, which means the value from the betterment are very reliable. Hence, we can clearly say that the shear wave velocity from the betterment, which is in-house device, is more closer and more reliable when we compare it with the lab testers, which calculated the shear wave velocity. In conclusion, the in-house device betterment is portable and we can get the shear wave velocity in an instant phase. It is proven that it's very reliable to use, because when we compare the value from the betterment with the shear wave velocities that taken from the lab test, it is most likely the same. So this in-house device betterment and also can reduce the duration to get the result and also the cost. I hope that I clearly concluded the objective of my final year project. Thank you for your attention.